morning. I hope that you have had good opportunity to work on the last couple of problems or last problem. I had three parts. Again, the differential equation part was one that I've seen most missed on the take-home portion that I gave you. So I wanted to look a little bit and just break it down. I'm going to go a little slower on this video, so this will probably be over the period of two videos. First thing they tell us is that dy dx is equal to y squared over x minus 1. Now, from that, what we want to do is we want to break this down and see what the different slopes are for the 6 points. Of course, they leave off 1 because when x is equal to 1, you get something that's undefined, and they don't really care that you know that it's undefined or not. I mean, they don't care that you know how to illustrate something undefined on a graph or not. So here's 1, and we just don't use 1. So we do this. Okay, well, anywhere that y is 0 and x is defined, you're going to have a slope of 0. So along the x-axis, we've got slopes of 0. And what you want to do, if that ever happens, you need to kind of draw it in and make sure that you have the that they can see that you've written a slope of 0. Now, as far as the rest of it is concerned, you've got the point over 0 and up 1. When you do that, you've got 1 over negative 1, which is a slope of negative 1. And then over here at 2, you end up with 1 over positive 1. So it's a slope of positive 1. Now, you go up to 2, this becomes 4 over negative 1. And this becomes, again, 2 squared over 2 minus 1. So this 4 over positive 1. Now, you don't have to really worry that much about the slope being exactly negative 4 and exactly positive 4. What you would just want to do is show that it's definitely steeper than that. If you wanted to, off to the side, show your work, that's fine. You could show your work and say, show that this is calculated as negative 4 and this is calculated as positive 4. But if you get the calculation right and you don't have the correct, if your slope doesn't match it, you won't get credit for it. So make sure that the slopes are done correctly. Okay. Now on to part B. Part B tells us this situation that f of 2 is 3. And they want us to do a tangent line. Well, if you think about a tangent line, at that point, you need a point and a slope. Well, how do you go about finding the slope at that point? Well, you need the derivative. I wonder what the derivative is. Oh, wait, the derivative's right up here, isn't it? So, f prime of 2 would be 3 squared over 2 minus 1. So it would be 9 over 1, which is 9. So we have the slope. So now to get the point there, 9 times x minus 1, 9 times x minus 2. This is m times x minus x sub 1 equals y minus y sub 1. So it's going to be equal to y minus, and then the y coordinate there is 3. So y minus 3. All right, so this is the blanket formula here. They want us to evaluate 2.1. So 9 times 2.1 minus 2 equals y minus 3. So 9 times 0.1, and I'll go ahead and bring the 3 over, plus 3 equals y. So y would equal to, and you could stop right there if you wanted to. That would be sufficient because you've replaced all the variables with numbers. But you would get 0.9 plus 3, which is 3.9. So y would be 3.9, or you could say y of 2.1 would be 3.9 or whatever according to the tangent line. So that's the tangent line approximation. Now I'm going to start another video for the actual solving of the differential equation part.